Okay, good day, class. This is another session for forensic chemistry and toxicology. And on this session, we will be presenting gun residue analysis, especially in application to law enforcement. But for this session, I'll be uploading and showing you two videos which you need to understand about gunshot residue analysis. Okay, so just stand by as I would present the videos.
To Mr. Michael Gorski. Mike?
Good afternoon. Today I'm going to talk to you a little bit about gunshot residue sample collection. We're going to discuss who you want to sample from, when you want to sample, where you want to sample, and also considerations to take into account when actually performing the sampling. Before we get into sample collection, I want to briefly touch on what gunshot residue, or GSR, is. Gunshot residue is the material that comes out of a firearm whenever it is discharged. This material includes elements from the gun primer, the gun powder, and also the firearm and ammunition itself. The portion of material that we are going to focus on today, the material that can link particles to a firearm's discharge, originates from the primer. The primer typically contains three elements that are highly specific to the discharge of a firearm whenever all three of those elements are found together in one particle. Those elements are lead, antimony, and barium. When a firearm is discharged, those elements originating from the primer can land on the hands, clothing, and surrounding area of the shooter. To hear a little bit more about the GSR particulate as well as testimony considerations, please be sure to tune into day 2 of our webinar series. Now let's talk about collecting those particles that may have landed on the hands, clothing, and surrounding areas of the potential shooter. When collecting samples for GSR analysis, the only type of kits that should be used are SEM or scanning electron microscopy kits. These kits are really the industry standard. GSR hand and surface kits can be purchased from a variety of different manufacturers, including Tritech, Cerchi, Arrowhead, as well as RJ Lee Group. The samples in the kit are what we refer to as a stub. A stub is an aluminum pin mount encapsulated in a plastic vial. The pin mount has an adhesive material on it that is used for the actual collection. Kits can contain anywhere from 2 to 5 sample stubs. Some kits only have stubs for the right hand and the left hand, and others like RJ Lee Groups have 5 stubs, stubs for the right back, the right palm, the left back, the left palm, and a control stub. It's really up to you and your agency as what type of kit to purchase. If you're ever in a pinch and do not have access to a GSR SEM kit, do not use a Q-tip or swab. At the very, very least, use a small amount of packing tape. However, if you have clothing or another item in-house for collection and are in need of a kit, give us a call and we'll quickly give you one free of charge. Now I'm going to go over the who, or what, you can collect from. GSR samples can be collected from a suspected shooter's hands or face area using those SEM stubs. At times, we do receive samples from victims' hands as well, and we can analyze for you if you deem them probative to the case. However, it would not be very unusual to see GSR on a victim of a gunshot wound. So typically, samples we received are from suspected shooters. Samples can also be collected from a suspect's clothing or other items related to the subject. This is sometimes a more probative path to take, especially if it has been several hours or even days after a shooting incident. GSR particles may tend to adhere longer to clothing than to the skin of a shooter. This is because the particles can get trapped in the weave of the fabric that the clothing is made out of. Typically, an individual is going to have washed himself or herself more often than they would have washed their clothing. Vehicles can also be a good source to collect GSR from if you suspect a firearm may have been discharged from within or next to a vehicle. Items that can be analyzed, including samples from hands, vehicles, all types of clothing, cell phones, helmets, sunglasses, purses, jewelry, just to name a few. Use your judgment. Think about what item is most likely to retain the most GSR after a certain amount of time has elapsed. And always, if you have any questions, just give us a call. We'll be sure to answer your questions. Now I'm going to go over the when. So when do you want the sampling to occur? So we frequently get asked on the stand when you should collect samples for gunshot residue analysis. The simplest answer to this question is to collect them as soon as possible after the incident. There are some labs out there that have what are called cutoff times. For example, if a suspected shooter isn't apprehended and samples aren't collected before a certain hourly time frame of a shooting incident, some labs will not accept the samples for analysis. This is because there are several factors, such as running, weather, activity, that can cause particulate loss. RJ Lee Group does not utilize a cutoff time, believing instead to follow what the investigating officers feel are instructions of probative value. Now, if you collect samples from a suspect's hands 3 days after a shooting, we will analyze them for you if that's what you want us to do. But the chances of still finding any GSR particulate are very unlikely. 3 days after a shooting, the probative value of collecting samples from an individual's hands decreases tremendously. It's cases like that that you want to look into taking samples from a subject's clothing or any other items worn during the time of the suspected shooting. Now I'm going to go over the where. So where should you actually collect the samples? If you should collect the samples as soon as possible, that typically means that you will be collecting samples at the scene. By collecting samples at the scene, there are fewer opportunities for contamination to be introduced and fewer chances for movement or activity of a subject over a period of time. However, we do realize that it's not always possible to collect samples at the scene. When you cannot collect at the scene, it is very important to bag the subject's hands. A brown paper bag over each hand of the subject will protect any possible contamination that could originate from a police officer's handcuffs or contamination that could originate from the back seat of a police vehicle. When collecting samples from the hands of a subject or bagging a subject before handcuffing him or her, we always recommend wearing latex gloves, and please do so. A pair of latex gloves serves to protect any potential transfer of particles from you to the subject. They also serve to protect you in court when you are questioned about best practices when collecting samples. Now I'm going to go over some considerations to consider when choosing what to actually sample and collect. There are many things to consider when collecting samples for gunshot residue. There are certain factors which can contribute to particle loss. These factors can play a role into whether or not samples will have probative value for analysis. So the first factor is, let's say, movement, motion, or activity. These are big factors which could potentially cause particulate loss. And the more time that passes, the more potential there is for particulate or particles to be lost. Washing hands, wiping hands on clothing, putting hands in and out of pockets, running, shaking hands with other people. These are all activities that could cause particles to be removed. This is also why clothing may be a better option for you to consider sampling if a long amount of time has passed since the incident. It may also be important to note a subject activities prior to the incident as well. For example, if a subject states that on the morning of the incident, he or she went to the gun range or that they went hunting, then finding GSR on them wouldn't really be that unusual. At that point, GSR analysis may not be very useful or a viable option for you in this investigation. Weather and airflow might affect the number of particles detected on a suspected shooter. When shooting incidents can occur outside, wind, rain, snow, or humidity could also wash away particles or affect the amount of particles that are deposited or particles that land on the shooter. Shooting incidents that occur inside can be affected by the movement of the air in the room. So let's say, for example, fans, air conditioners, or even having the windows open may affect particulate loss or the number of particles that can be deposited on a suspected shooter or the area. So another consideration to take into account might be blood or other biological material. So this biological material can act as a mask for particles that are on a subject's hands or clothing, making them not readily able to be collected. When collecting samples, it is important to try and sample around the areas that have a lot of biological material present. So contamination from other sources is another issue to consider when collecting samples. Officers collecting from subjects need to be especially cautious as they and their surroundings can potentially contain GSR particulate. As mentioned previously, wear gloves and be aware of potential contamination sources around a collection area. If possible, have an unarmed officer collect the samples. It is not uncommon to find only one or a few GSR particles on a case sample, and you do not want to be a possible source of these particles. As I stated previously, if collection cannot be done at the scene, it is highly recommended that the subject's hands be bagged before being cuffed. This is done to prevent any contamination from getting onto the subject's hands. If you will be collecting samples at your agency, be sure to wear gloves, ensure a clean environment. For example, don't collect samples in a ballistics unit, and clean surfaces before the subject is brought in for sampling. Make sure to lay out paper, do things that will prevent contamination. We also want you to consider packaging. When you are packaging clothing to be sent for sample collection, the items should be packaged individually so no contamination or cross-contamination in this instance could occur. Each article of clothing can be wrapped in butcher paper and then placed in separate evidence bags. Now let's take a closer look at the gunshot residue hand kit. This particular hand kit contains 5 stubs, so stubs for the back and palm of the right hand and back and palm of the left hand, as well as a control stub. When using the right back or right palm stub, that should correspond to the subject's right hand. The left back or left palm stub should correspond to the subject's left hand. The control stub is a stub that can be utilized however you see fit. It can be used to sample in the area or room in which the samples are being collected to prove that it is free of GSR particles, or it can be used to sample the hands of the individual doing the collecting. Some agencies choose to use the control stub as a kind of batch control to prove that there is nothing present on the stubs before they are being used to sample. The use of a control stub is completely and totally up to you, but using them does help to bolster credibility in the courtroom. The first step is to prepare yourself before collecting samples. Take note in the picture. The individual doing the collection is wearing appropriate personal protective equipment with latex gloves while doing the sampling. So now I'm going to go over how to actually sample from a suspect's hands. This image would be representative of the back right hand of a suspected shooter. So the method used to sample areas of interest is called particle extraction. It's basically a simple dabbing motion. First, you want to remove the cap from the stub. Then you place the stub face down on the area of interest. In this picture, we are seeing the right back of the hand, and every circle represents one individual dabbing motion. When sampling hands, you want to focus first on the area that usually has the greatest concentration of particles. The area and webbing between the individual's thumb and forefinger. This is shown in these white circles. Once that is complete, you want to start dabbing up and down the hand in a vertical motion, ensuring to cover the entire hand. Be sure when you dab that you put the stub down and then bring it right back up. Please do not drag the stub along the surface of the skin. That could cause the adhesive to curl up on itself, degrade, or possibly mask particles that are being present. So these blue dots represent a vertical motion of dabbing across the subject's hands. So once you have dabbed over the hand in the vertical direction, you want to dab over the hand in the horizontal direction, and that's what's going to be represented by these black dots. This will create a grid-like pattern over the entire hand, ensuring that the entire hand has been sampled. So now I'm going to go over some sample collection from, let's say, an article of clothing. When sampling clothing or other items, the same method of particle extraction is used. The dabbing technique is applied in a vertical and horizontal direction, creating a grid-like pattern over the area of interest. When samples are taken from clothing, typically more than one sample is needed. This is because the adhesive properties of the stub will wear off over time and in the amount of area being sampled. As an example, when collecting samples from a long-sleeve t-shirt, jacket, or sweater, as shown in the picture, we would use 4 different stubs to sample the item. One for the right sleeve, one for the right front side, one for the left front side, and one for the left sleeve. This ensures that the entire area of the sweater would be sampled. Other areas of clothing that can be sampled are based upon what you feel is of probative value. For example, it is possible to particle extract from, let's say, the pockets or waistbands if you believe that a recently discharged firearm may have been holstered in those areas. So it's really up to you. Particle extractions of clothing and other items, let's say purses, phones, sunglasses, can be sampled at your agency, given that you have an appropriate area and clean room to use. Or if you don't feel that you have a clean, contamination-free area, they can always be sent to the lab, like RJ Lee Group, and we can sample there, followed by the analysis. So now I'm going to go over sample collection from vehicles. Vehicles are another common area for GSR samples to be collected from, obviously depending on the nature of the case at hand. The same method of particle extraction is utilized on the vehicle as is utilized on hands and clothing. Potential areas to sample from, including, but are not limited to, let's say the seats, headliners, door paneling, consoles, dashboard, steering wheel. The list goes on. When sampling from a vehicle, consider the flow of an incident before collecting. So what I mean by this, if a potential shooter fired a gun out of the driver's side window, you would want to collect samples from the driver's door before you collect samples from, let's say, the passenger seat or a rear passenger seat. Another thing to consider is the material of the surface that you are sampling from. Particles are going to tend to adhere better to fabrics than, let's say, vinyl, plastic, or the metal on the outside of a vehicle. If at any time during the investigation of a case you feel that you have a question about what areas may or may not be of probative value, please feel free to let us know and give us a call. We can always aid you to determine whether or not collecting samples for GSR is a viable option for you in your particular situation. So now I want to go over why correct sampling is incredibly important. In an ideal world, every sample that you would collect would have, let's say, hundreds to thousands of GSR particles on them. Well, that's possible. They could, and we have seen samples that have hundreds to thousands of particles on them. However, let's be realistic. We tend to see samples with a few particles on them, maybe one particle on them, or no particles on them at all. This is because of all the factors that I went over previously. Let's say weather, motion activity, time, washing, etc. Because of these factors, you want to make sure that you are collecting any and all potential particles that could be present to be collected. Therefore, we want to make sure that you're sampling correctly and efficiently. By sampling properly, not only are you ensuring that you are collecting any and all particles present, but you are also ensuring an easier time testifying. You can say under oath that you have sampled correctly and appropriately based on the standards set forth in the field. Now I'm going to go over some packaging considerations. Once samples are collected and ready to be sent off for analysis, you'll need to be sure they are packaged properly. Proper packaging is one way that possible contamination can be controlled. GSR hand kits typically are sent in evidence bags with samples, latex gloves, and seals. After collection, the samples should be placed in the evidence bag with the sealed with tape. When packaging clothing, items should be packaged in butcher paper prior to packaging. When multiple items are contained in one bag, cross-contamination can occur. Therefore, only one item should be placed in a bag. Now, this is important, especially if you have items that are coming from multiple people. Please do not place multiple items from multiple people in one bag. Please remember, the bag should be sealed completely with no rips or voids. Evidence tape should be used with your initials and date on the seal of the package. Please, please do not seal the bags with staples. We will photo document this and it may come up during discovery. Once samples are packaged, they are ready for shipping, and now Marcia is going to talk to you a little bit about that portion of our analysis.
Hello, everyone. My name is Marcia Hess, and I'm the project coordinator in the forensics department. If you call our daily group and ask to speak to someone in the forensics group, I will probably be the one to take the call. Some of my other responsibilities include logging evidence into our database upon processing, as well as scheduling our experts for trial testimony, conference calls, and depositions. Today I'm going to go over the proper procedures for submitting evidence to our laboratory for analysis. As Mike stated, all evidence should be properly packaged and sealed. A chain of custody or a submission letter should be included with the evidence. Let's talk about the chain of custody. If your agency has a chain of custody, please enclose it with the evidence. If you need to obtain one, you can download one from our website. You can go to www.rjleegroup.com. Click on Submit a Sample. Under Complete a Chain of Custody, you will see three options. We have a General COC, IH Environmental COC, and a Vermiculite Analysis COC. For submission of forensic evidence, you want to choose the General COC. This is what the General COC from our website looks like. This form is self-explanatory. The fields that you want to pay close attention to are the report results to, the send invoice to, and the client sample ID. Please list the items that you're submitting so that we can verify what you sent is what we received. If you prefer not to use our online form, we ask that you enclose a submission letter with the samples. Here is an example of a submission letter, and we first want to make sure that you submit this letter on your company's letterhead. We also ask that you include the following information: the type of analysis, such as gunshot residue analysis, the case number, which would be your police department's or agency number, a list of evidence submitted for analysis. Again, so we could verify what you sent is what we actually received. We would also like for you to include a brief synopsis of the case, such as subject, victim names, right, left-handed. The reason we ask for this information is because a lot of times we'll do some casework and a year later we'll receive a subpoena for testimony. The subpoena number will be different than the agency case number. Without subject names, we can't reference what case needs to go to trial. So it's very helpful. The more information we have, the better chances we have of linking everything up as it comes up later for trial. The next thing that we ask is you list the report to contact information, which would include name, address, phone number. If the billing information is different than the report to contact, please list that. A lot of times we'll get evidence from the police department, however, it's going to be billed in the district attorney's office, and that's helpful so we can get this right the first time. Evidence can be shipped through any means that provides that package with a tracking number, such as UPS, FedEx, U.S. Postal Service, certified mail. Evidence can also be hand-delivered to our Lee group. We have a lot of local agencies that just come on and drop their evidence off for us, and we'll have chain of custodies ready when you arrive, and we can accept your evidence at that time. Once we receive and process the samples, our standard turnaround time is 5 to 10 business days. Upon completion of analysis, we send all of our samples back using UPS unless you instruct us otherwise.
Okay, so I hope you learned from the first video with regards to gunshot residue analysis. And I will provide the next video. It is a continuation of the first video. So please stand by as I will present the next video.
Forensic scientist at RJ Lee Group. Today we're going to talk about the analysis of gunshot residue as well as considerations when testifying to the evidence. At the conclusion of this webinar, you'll be receiving an email in about 2 to 3 days' time, including a link where you will be able to view the webinar in its entirety. Along with that link, you'll also be able to see day 1 of our webinar series. At the end of the webinar, there will be a brief question and answer session, and we encourage you to ask questions. If at any time during the presentation you do have a question, please feel free to use your question tool, which is located on the panel on the right-hand side of your screen. We will get to as many of your questions as possible during the question period at the end of the presentation. If we are unable to get to your question, we'll contact you after the webinar to be sure that everything that you have a question about is addressed. Also, if you do need a certificate to show that you attended the presentation, you can request one by using the question box. Please include the name you would like on the certificate as well. So at this point, I'd like to turn it over to Stephanie Horner to talk about the scientific aspects of gunshot residue. Steph?
Last week, Mr. Gorski went over the collection of gunshot residue. He covered the who and what and how of collections. I'm going to start by giving you a background on gunshot residue. What exactly is GSR and how is it created? In the broadest sense of the word, gunshot residue is all particulate that is expelled from a firearm during discharge. For the purposes of this webinar, when I refer to gunshot residue, I am specifically talking about primer gunshot residue. There are many components to gunshot residue. If you look at the picture of the cartridge on the right, you can see where all the particles that make up gunshot residue originate from. At the very bottom, you have the primer cap. Inside the primer cap is the primer paste. The primer paste is typically composed of lead, antimony, and barium. Those are the elements that we look for when we are looking for gunshot residue. It is important to note in the image that you are looking at, this is a center fire primer cap. Depending on the cartridge, you could also see a rim fire. Next to the primer, you can see the propellant or powder. The powder is composed of nitrogen-based compounds, including nitrocellulose and nitroglycerin. These components are important when analyzing evidence for distance determination. While RJ Lee Group can perform distance determination, I am not going to cover it in this webinar. The bullet is next to the powder. It is what is forced out of the firearm during discharge. In addition to seeing elements from the primer and the powder in a population of gunshot residue, we also see some other metals from the ammunition and the firearm itself. Aluminum or tin can come from a thin layer of tin or aluminum foil that is used to separate the primer and the powder. Now you know where gunshot residue particles come from, but how are they actually produced? When the trigger on a firearm is pulled, the firing pin will strike the back of the primer cap. This causes the primer residue to burn, which in turn ignites the gunpowder. The burning of the powder results in a lot of pressure and heat within the firearm. The pressure will force the bullet out of the firearm. While this is happening, all of those tiny particles from the primer and powder escape out of the firearm through any opening. They will come out the muzzle, the ejector port, or any other opening in the firearm. As the elements cool, they condense and land in tiny particles on the shooter and the surrounding area. Those particles can be collected using an SEM stub as described in day 1 of this webinar. This image shows the cloud of particulate that is expelled from a firearm when discharged. The cloud is often referred to as the plume. Remember, this plume includes particles from the primer, powder, and other miscellaneous metals from the cartridge. In this plume, there are hundreds or thousands of microscopic particles that will condense and fall on the hands of the shooter and surrounding area. The particulate from the plume is actually what you will be collecting. From that plume, the particles that we are most concerned with are the primer particles. let's take a closer look at those particles. The plume is typically a high temperature, supersaturated concentration of three important elements: lead, barium, and antimony. As the temperature cools, those elements are going to condense into different combinations, creating 1, 2, or 3 component particles. 3 component particles are what we refer to as characteristic of gunshot residue. They are highly specific to the discharge of a firearm. 3 component particles contain the elements of lead, antimony, and barium. We must see all 3 of the elements in the same particle for that particle to be considered highly specific to gunshot residue. In addition to the correct elements, we must also see the correct shape or morphology. The particles must be round or molten, as if they are heat treated, since the discharge of a firearm is a very high heat reaction. These are the particles that have to be present in order for a population to be considered gunshot residue. 2 component particles contain 2 of the 3 elements. So that would be a particle that contains lead and antimony, or lead and barium, or barium and antimony. 2 component particles are considered consistent with the discharge of a firearm. 1 component particles contain just 1 of the 3 elements. So a particle of just lead, or a particle of just barium, or a particle of just antimony. 1 component particles are considered commonly associated with the discharge of a firearm. However, there are some brands or types of ammunition which could create different compositions. For example, some .22 rimfire can lack antimony in the primer, or there are non-toxic ammunitions which could be lead-free. In addition to lead, barium, and antimony, there are other elements which can be found in gunshot residue but are not required. Some examples would be silica, copper, tin, or aluminum. There are also elements that when seen with lead, barium, or antimony, that would cause us to eliminate that particle as coming from the discharge of a firearm. Some examples would be magnesium, chromium, or titanium. The presence of these particles would let us know that it is likely that particle came from some other source besides gunshot residue. For example, particles containing magnesium can be found in fireworks. Primer gunshot residue particles are so small that they cannot be seen by the naked eye. This is why we require a high-powered microscope to view the particles. In this picture, you can see a human hair next to a gunshot residue particle. You can fit 20 to 100 gunshot residue particles across the width of a human hair. This is an image showing a gunshot residue primer particle taken using the scanning electron microscope. Here you can see the peaks representing each particle. The lead peaks are labeled with PB, the antimony peaks are labeled with SB, and the barium peaks are labeled with BA. You can also see the elements of silica labeled as Si and tin labeled as Sn. It is possible to see both silica and tin in gunshot residue. Another important thing to look for is the shape of the particle. As you can see, this particle is round. Gunshot residue particles have a round and molten appearance due to the high heat reaction. The image you are looking at is magnified using the SEM. The image on the left is magnified 400 times, and the image on the right is magnified 2,000 times. The particles need to be magnified thousands of times in order to be viewed since they are so small in size. The scanning electron microscope, or SEM, is the most current and up-to-date method for gunshot residue analysis. You can see from this image the SEM is controlled by and the particles are viewed on a computer screen. The SEM allows us to see gunshot residue particles and analyze them. All gunshot residue samples are analyzed using the SEM at RJ Lee Group. The samples are loaded into the microscope. A beam of electrons is aimed at the sample. The interaction of those electrons with the sample electrons determines 2 things. The first thing is the elemental composition of the particle, or what that particle is actually made out of. The second thing is the shape of the particle. The SEM has a 2-part analysis. The samples are first analyzed using an automated analysis. The SEM scans back and forth across the surface of a sample, looking at the elemental composition of all particles. The instrument marks the location of any particle of interest. The second part is a manual analysis. The analyst will look at the particles of interest that the SEM found and confirm that the instrument made the correct calls. The particles that are confirmed during the manual analysis are the particles that we report out. The average analysis time using the SEM is 4 to 8 hours per sample. A case can take much longer to analyze depending on how many particles are found on each sample and how many samples are in each case. If you have a typical hand kit with 5 stubs for analysis, this can take anywhere from 20 to 40 hours or even longer. There are some outdated methods for gunshot residue analysis that I'm going to touch briefly on. Most of the outdated methods for gunshot residue analysis are actually testing for the powder residue and not the primer residue. Some of the other tests for GSR are the paraffin or dermal nitrate test, instant shooter identification test, or the rapid identification friend or foe test. These tests look for nitrogen-based compounds or powder residues. The ISID and RIFF tests can be used in the field and give instant results. However, these tests are presumptive and not confirmatory. These tests can result in false positives or false negatives. Some false positives include fertilizers, tobacco, and certain foods. These tests are often marketed as tests for primer residue when they are actually looking for powder residue. The only analysis that is confirmatory is primer analysis. The atomic absorption test also looks for lead, antimony, and barium. However, it is a bulk analysis. This means that it can only determine whether the sample contains lead, barium, and antimony, but cannot tell if they are present together in one particle. The atomic absorption test does not look at individual particles, which is necessary to determine the presence of gunshot residue. There are many reasons that the SEM is used over other methods for gunshot residue analysis. The SEM is a confirmatory analysis. It is not a presumptive test like some other field tests used for gunshot residue. The confirmatory test allows us to say whether or not primer gunshot residue is present. The SEM can look for individual particles and can aid the scientist in determining if that particle came from the discharge of a firearm. SEM kits are inexpensive and can be stored indefinitely. The kits do not expire and can be used whenever you need them. SEM samples are fast and easy to collect, and sampling can easily be performed at the scene. The SEM is a non-destructive technique. This means that the evidence itself is not destroyed during analysis. For example, gunshot residue samples can be taken from a shirt, and the shirt can still be sent for DNA analysis after the gunshot residue sampling. The samples can be analyzed as many times as you would like, getting the same results each time. It is easy to duplicate the analysis. These are the reasons why we always recommend SEM analysis over other types of analysis. Not only because of the reasons I just listed, but it also holds up in court. Allison is going to go over some testimony considerations with you now.
Thanks, Steph. Yes, gunshot residue analysis via the scanning electron microscopy does hold up well in court. It is the standard and approved technique by experts in the field. When testifying to gunshot residue evidence, there are several considerations that it's important that you be aware of when submitting samples for analysis. There are certain things that we can say and certain things that we can't say when testifying. Today, we're going to give you a little insight into how our testimony might be able to help your investigation. A lot of the questions we get asked about in court revolve around what we call hypothetical situations. Lawyers want to know and want to get this across to the jury how much gunshot residue they can expect under certain circumstances or certain conditions. Situations like these are difficult to predict because there's so many variables that can come into play. Really, the best way to answer a hypothetical question is by giving back some hypothetical scenarios. So that's what we're going to do today. Let's first take a look at an ideal scenario. This is a situation in which everything goes according to the forensic plan. Basically, the stars are aligned and the world is just a perfect place and everybody's happy. In this situation, the shooting takes place in what we call a static environment. What this means is whether or not the incident takes place indoors or outdoors, there is no airflow or weather conditions to be aware of. If it's inside, there's no air conditioning, there's no fan, there's no air movement. If it's outside, there's no rain or wind. Let's also assume that the firearm is functioning properly. Let's imagine that it creates a lot of gunshot residue whenever it's discharged. Let's also assume that the samples are collected from the hands or the clothing of the shooter immediately after the discharge, not leaving any time for the shooter to move to wash or wipe his hands. There's absolutely no activity before the collection of the samples. We're also going to assume that the shooter's hands are clean. There's no debris or dirt or biological material like blood or sweat or saliva on those hands. We're also going to assume that the area in which the firearm was discharged is free of contamination. Let's imagine that it's clean and free of GSR-related particles that may be present due to contamination from a previous discharge. Finally, let's assume that the room remained untouched after the discharge. There was no activity in the room that could cause particle loss or particle movement. In this ideal scenario, we would expect for hundreds to thousands of gunshot residue and gunshot residue-related particles to be produced from the discharge of the firearm. It would be likely that a lot of those particles would then be collected, and the conclusion of the testing would portray a large positive result. Just a note, however, that a large positive result doesn't mean that you will see hundreds to thousands of particles in your report, because in cases like that, we're only going to confirm a representative number of particles to prove that positive result. While having an ideal scenario would be excellent, we also recognize that it's not at all likely. So now let's take a look at what we would consider some not so ideal or more realistic scenarios. A lot of these scenarios are ones that we get asked about a lot in court. Let's say that we have a situation in which a firearm was discharged in an area where there was definite airflow or weather conditions, either inside or outside. Now let's assume that the firearm was used is a poor producer of particles. Say it's relatively closed off or sealed off and just doesn't produce a lot of gunshot residue particulate. Let's also assume that the samples aren't collected from the shooter until much later after the discharge, hours or even days, leaving plenty of time for the shooter to actively wash or wipe his hands or change his clothing. We could also imagine that there was dirt or debris or some type of biological material present on the shooter's hands. In these more realistic situations, which we often get asked about in court, there's a variety of different outcomes which could be expected. It still is possible that hundreds to thousands of particles could be produced and that a lot of GSR would be collected and analyzed. However, given these influential factors, that result is pretty unlikely. What is more likely is that the analysis of these samples will show some GSR and GSR-related particles, or even no particles at all. It's important to note the reasons why samples may come back as inconclusive. There's many different factors that can contribute to that particulate loss, as we've mentioned. Keep in mind that if at any point in time you have a question as to whether or not it would be probative to have a certain item of evidence analyzed, you can always give us a call and we can help you with any case scenario you might be curious about. Many times in these more realistic scenarios, we will ask that you send any clothing that you might have for analysis, as particles are going to tend to adhere more closely to the weave of the fabrics than to skin. So with all of these different factors and all of these different mitigating circumstances which could contribute to particulate loss, it seems that there could be a wide range of possible outcomes. So that might lead you to ask the question, why then? Why should I collect samples for gunshot residue analysis? Well, there's several reasons. First and foremost, once gunshot residue samples are collected, they can last indefinitely. Once that particulate is on the SEM stub, it's not going to disintegrate or be lost over time. It's always better to collect the samples and have them and then decide not to have them analyzed than to not collect them and need them at a later date. Secondly, collecting samples creates a very thorough case examination. In today's world and in light of the CSI effect, juries are coming to expect a complete and forensically sound case investigation. Not only does it create a full picture for a jury, but it also enhances your credibility as a witness on the stand. Lastly, and most importantly, gunshot residue can be probative evidence providing strong investigative leads. Analysis by SEM is confirmatory. You can say definitely that there is a population of gunshot residue present. It's up to the jury to decide how it got there, but we can definitely confirm whether or not it is there. GSR is a piece to the forensic puzzle. It works in conjunction with other evidence to create a complete case against an individual or individuals. When we testify in court, there are some terms that you will most likely be hearing, which we're going to go over, and Stephanie touched on these briefly. These terms actually originate from a group called SWIG GSR, SWG GSR, or the Scientific Working Group for Gunshot Residue. This is a group of gunshot residue experts from all over the world who created a guide for the analysis of primer residue. This guide has become somewhat of a standard in our field. Within a population of gunshot residue, you will most likely see a combination of 3 particle types, which SWIG GSR refers to as characteristic particles, particles consistent with gunshot residue, and particles commonly associated with gunshot residue. Particles that are characteristic of GSR, as Stephanie mentioned, are particles that contain a combination of 3 important elements: lead, antimony, and barium. These particles are highly specific to the discharge of a firearm. When they are found on a sample without any other extraneous elements, we can say that they came from the discharge of a firearm. Particles that are consistent with GSR are most often 2-component particles or particles that contain 2 of the 3 important elements. They contain either lead and barium, lead and antimony, and/or barium and antimony. Finally, particles that are commonly associated with GSR are most often 1-component particles or particles that contain 1 of the 3 important elements of either lead, antimony, or barium. When talking about a population of GSR, it's typical to see characteristic particles as well as particles consistent with GSR and particles commonly associated with GSR. Those 3-component, highly specific characteristic gunshot residue particles, when they're confirmed on a sample, we can say that a sample is positive for gunshot residue. And when that primer GSR is found, it means that one of these 3 scenarios occurred. The subject could have either A, discharged a firearm, or B, been in proximity when a firearm was discharged, or C, they came into contact with a surface or an environment that contains GSR. Each of these scenarios is equally likely or possible under most conditions. And we have to say most conditions because there are some conditions in which one of the explanations is not as likely as another. For example, if you were collecting samples from a vehicle, the vehicle obviously cannot discharge a firearm. Therefore, if GSR is found in a vehicle, it means that a firearm could have been discharged in or near that vehicle, or someone or something that had GSR on them came into contact with that vehicle. When no particles are found, or if only 1 and 2-component particles are found, the results are deemed inconclusive. We don't call this a negative result. The absence of characteristic particles does not necessarily mean that the subject did not discharge a firearm or was not involved with a gun-related crime. It's possible that there were particles on them at one point in time, but they could have been removed by factors that we went over previously. Because of this fact, we term results in which there are no characteristic particles as inconclusive. Along with analytical results, there is a part of every GSR report that is called qualifiers. RJ Lee Group includes this section, as do most other crime laboratories. This section does just as it states. It qualifies the results of the analysis and aids in the interpretation of their meaning. RJ Lee Group includes 3 qualifying statements in GSR reports. We've already somewhat discussed these qualifiers, but for clarity's sake, we're going to go over them one more time, and they are as follows. Number one, GSR can be deposited by circumstances such as discharging a firearm, being in the proximity of a discharging firearm, or coming into contact with a surface or object that has GSR on it. Again, when those highly specific characteristic particles are confirmed, each of these scenarios is a likely possibility as to why and how those particles got there. Number two, two-component and one-component particles are found in GSR, but may also originate from other sources. Because one and two-component particles can come from other sources aside from the discharge of a firearm, we cannot term them characteristic, but rather consistent or commonly associated with GSR. And finally, the absence of GSR does not eliminate the possibility that the subject handled or discharged a firearm. Again, if samples are determined to be inconclusive or not have any characteristic GSR on them, it could mean that the subject did not discharge a firearm, but it could also mean that the particles were removed by some other means, such as washing or wiping the hands. Along with these qualifying statements, there are a few other testimony considerations to be aware of that might come up during trial. One of which is the fact that the FBI no longer analyzes GSR. We're often asked on the stand if we are aware of that fact. And we're also asked if we're aware of the fact that the FBI no longer analyzes GSR samples because they consider it junk science. Well, we are aware of the fact that the FBI no longer analyzes GSR, but it is not because they believe it to be junk science. The FBI no longer analyzes GSR because they were getting less than 10 cases per year involving the analysis. The decision was then made to direct their resources to areas that were more closely related to their priority of combating terrorism. The FBI still stands behind any and all reports that were issued concerning GSR in previous cases, and they simply forward on any current GSR casework to other laboratories who have the capability to test it. The Guide for Primer GSR Analysis includes a memo from Mark LeBeau, the Chemistry Unit Chief of the FBI Laboratory, stating just this. If you're interested in reviewing that memo, you can go to www.swiggsr.org, click on the link for the guide, and go to page 64, and you'll see the memo in its entirety. Another consideration that we are often asked about during our testimony are other sources that create particles that are similar in nature to primer GSR. There does exist a very narrow category of sources that can create particles that are similar to three-component GSR particles. Those sources include a certain brand of nail gun and ammunition, which is no longer being manufactured, a certain type of firework, the deployment of an airbag in a vehicle, or certain types of brake pad linings or brake pad dust. It's important to note, however, that populations of particles from these sources may also include certain elemental tags that would indicate to an analyst that they are not looking at a population of particles from gunshot residue. For example, particles coming from fireworks are likely to have magnesium or chromium in them as well, elements that are not typical in gunshot residue. Or particles coming from brake dust also tend to have high amounts of iron with rigid or jagged morphologies. These are indicators to an analyst that the population is not GSR. Along these same lines, it's also important to take a subject's occupations or hobbies into account. For example, a mechanic who is more likely to have access to brake pads or an avid hunter are more likely to have gunshot residue-related particles on them. One other consideration to mention is the fact that you, as police officers, can be a source of contamination. Studies have shown that it is possible to get GSR particles from the back of a police officer's vehicle or from the handcuffs of a police officer who had cuffed someone previously. It's not often a lot of transfer, but it is possible. Because of this, we always recommend sampling at the scene. And if that is not possible, bag the hands of the subject before you place them in handcuffs or put them in the back of a police cruiser. And always, when collecting samples, be sure to wear some form of personal protective equipment, such as latex gloves. As with any type of forensic testimony, there are some limitations to what we can say on the stand. One of those limitations include the fact that we cannot age gunshot residue. That if we find particles on a sample, we cannot say what incident put those particles there. The more recent the discharge, the more likely it is that the particles came from that incident. But it is still possible that they could have come from another previous incident. When asked about that on the stand, we do have to say that it is not possible to link the GSR found to one particular incident over another. It is also not possible to link the particulate found to a particular firearm. The majority of ammunition used is going to create the same type of particles, characteristic particles containing lead, antimony, and barium. Because these particles are produced with the vast majority of shootings, it's not possible to link the particulate to one firearm over another. And finally, again, it's important to note that as analysts, we cannot say who the shooter was. What we can do is confirm whether or not GSR particles are present. When they are present, it works as a piece to the case investigation. The jury decides how they got there, but we can confirm it. At this point in time, that concludes our session on analysis and testimony considerations, and I wanted to say thank you very much for joining us. Have a wonderful afternoon.